Lesson 8.1 is on solving problems involving scale drawings. So if you look on page 415, just as an example, there's a scale model of a plane. Basically, when they make scale models, they're trying to make something proportional to the original object. A lot of times scale figures or scale models are going to be smaller than the actual thing. Like with this airplane, we probably wouldn't want to build a bigger than a regular size airplane to try and have that as a toy or something. Probably wouldn't work out too good, wouldn't fit in our closet or anything. But some cases there might be where we would make something bigger. But the idea is always to keep it proportional. So like if we would measure the wingspan on this plane, how far it is from front to back, and different things like that, we would try to keep it proportional. In other words, if we made the wingspan like 1,000 times smaller than the original thing, we would want to make the distance from front to back also be 1,000 times smaller. If we don't do all of these, proportionally the same way, dividing them, then we're going to end up getting something that doesn't look like the original object. By doing it proportionally, we get something that looks the same or similar anyway to the original object we had. Cases sometimes where we might want to make something bigger. For example, I used to have a poster of a calculator that had the buttons on the calculator, and then that would be a way then I could show you where buttons were on your calculator. I didn't really have a good spot to put it up in the front of the room here, so that's the reason why I used to have it in the back and it fell down, and I didn't mess with trying to rehang it because it really wasn't convenient for everybody to be turning around and trying to look over the top of my desk and see where the buttons were. But anyway, cases like that, cases like in science, sometimes there's things really small and we might really enlarge something like a cell or something like that so we can see better what it looks like. So if you look at example 1, we have an island in a blueprint that's 6 inches long. What is the actual length of the island in the kitchen? So here they're just defining what a scale drawing is. So it's enlarged or reduced drawing of an object that's proportional to the actual object. In scale drawings, they should give us what the scale is. So notice here the scale 1 inch is equal to 1.5 feet. And then what we can do is we can do a proportion and figure out what our missing number is. So in this case, I would do this a little bit different than what the book is. So 1 inch is equal to 1.5 feet. What I like to do when I'm doing these problems is just to start with the scale that they give me and write that as a fraction. So again, this is not the same way quite of how the book's doing it. It's a similar idea, but a little bit different. So 1 inch is equal to 1.5 feet. And then what we can do is we can make this proportion. Since they told us, and this is what I like to do. This is how most books do this. For some reason, this book's not doing this. But usually we put the model length on the top and then the actual length on the bottom of our fraction. And so in this case, the model length is on our blueprint, which was 6 inches. Usually when you do these proportions, the units are going to be the same straight across from each other. So notice inches in both of our numerators, and then we're trying to find the actual length of that island. So what we can do then is find a pattern here. You can use whatever variable you want to. The more I've thought about it, I think X is just an easy letter for people to use because as quick as you can be writing it, if even you're sloppy, it still is going to look like an X. That's kind of my thought process. Anyway, so this is the pattern, is that we're multiplying by 6. and then if you multiply those just like the book did, you'll get 9 feet. I know on some of these problems you guys might look at it and you might say, well, yeah, if 1 inch is that and this is 6 inches, it's just going to be 6 times that amount. That's fine. You know, if you're for sure confident in what you're doing with that. Sometimes I just like to have a proportion just to kind of verify that I'm doing it correctly, because there's times you might be multiplying, there's times you might be dividing. If you set up a proportion, there's less of a thought process that has to happen once you have it set up. I can just look at it and say, oh, I'm multiplying by this number. Oh, I'm dividing by this number. If you don't set up a proportion, there's a little bit more of a question of, am I doing this right or not, in my opinion. So if you look at the try it, they're asking what is the actual width of the island if the width of the drawing is 2.5 inches. Again, I'm just going to start with the scale. So I'm doing this different than the book again. I'm just going to start with that scale they gave me. So it says the width in the drawing is 2.5 inches. So 2.5 inches would go in the numerator, and then we're trying to find this other dimension. If you want to do W for width here, you can. If you want to just do an X, it doesn't really matter what variable you choose. So on this one, we can look for a pattern, multiplying or dividing. In this case, if we go from 1 to 2.5, that'd be multiplying by 2.5. And if you multiply that out, you get 3 and 7/500. 3.75 feet would be the width. And again, the way the book did it, it's fine. It's just inverted, you could say. Everything's just flipped upside down from what we did. Normally you can find good patterns on these, so I think maybe what the book's trying to do is have our variable in the numerator. If the variable's in the numerator, you can say it's being divided so we can multiply. Where if it's in the denominator, we'd have to invert both of our fractions in order to do that. But really 9 times out of 10, you guys are going to find a good pattern here. And so I wouldn't really worry too much about it. I would just start with the scale factor they give you, the scale that they give you, and then just look for patterns. If it doesn't work, you can flip those around, or you can cross multiply, or you know, different ways you can solve that. Example 2, they're asking what the area is of the deck represented by the scale drawing. So again, I'm choosing to do this a little differently than the book. To find the area, we actually need to know what the actual length and width of the deck are. So again, we can do proportions, or I know you guys can probably just kind of figure out what's happening here. So like for the width on the drawing, it's 8 centimeters. So this would just be multiplying by 8, which would give us a width of 16 yards. And then we can do the same thing for the length. Just start with the scale they give you. This is 16 centimeters. We're trying to find the length. So this would be multiplying by 16. 2 times 16 is 32. So that would be 32 yards. Now, I know we can feel accomplished. We've done a lot of stuff. Always make sure you're answering the question. We have not yet answered the question. The question is, what is the area of the deck? So to find the area of a rectangle, we're going to multiply the length times the width. So 32 times 16, and that's in your book there, is 512. So 512 square yards would be the area. Oh, it's right there. If we look at example 3, students are recreating the landscape drawing shown at the right for a mural. They want the length of the drawing on the mural to be 80 inches. What will be the new scale and the height of the drawing on the mural? So I'm going to do this different than the book. So here's the scale, and they give us what the dimensions are of this. What we're doing is we're going to be doing a different size than what we've got right here. So to me, I think it makes sense, first of all, if we try to figure out what the actual length and width are. Like, we know this is some kind of a picture of it, but if we can find the actual dimensions, I think that's going to be helpful for us on this problem. So if we've got 1 inch is 4 feet, and then just to clarify, usually the width is the smaller dimension, the length is the bigger dimension. So we can just try to figure out what the actual width is. So we know on this picture it's 8 inches. We're going to try to figure out what the actual width is. So we have a pattern here, would be multiplying by 8. So that would mean our actual width is 32 feet. And then we can do the same thing to figure out the actual length. So on the picture, our length is 10 inches with a scale of 1 inch being 4 feet. So this has a pattern as well, multiplying by 10. And so that means our actual length is 40 feet. Now, we're not finished yet, but we at least know what the actual dimensions of this thing are. And now we can work with that in order to find what our scale is, and then to find what the height needs to be. And what I just went through there, I called it the width and the length. I mean, how the book's calling it, I guess we could call that would be like our height. All right, so what we're going to do at this point is we can find our new scale. So we're going to be doing a different scale than what they had before. So we've got, on the one that we're going to do, we want the length to be 80 inches. In reality, so this is looking at our length, okay, because they told us what the length is going to be. So 80 inches, and in reality, it was 40 feet. In order to set up your scale, if you've noticed the scales so far, it's been like 1 centimeter equals this, 1 inch equals this, okay? I mean, technically this is a scale. 80 inches equals 40 feet. It's not a very convenient scale, because then if I'm trying to find patterns, if something's like 15 inches, well, how do I get from 80 to 15? Not very nicely. So what we want to do is give a nice scale like we've been given on these other problems. We want to figure out what 1 inch is equal to, and then we'll be able to use that to easily figure out anything. There's always a pattern, because 1 times whatever the number is that number. You know, 1 times 7 is 7 inches, for example. So whatever you want to put for your number here, but this would be dividing by 80. 80 divided by 80 is 1. And so 40 divided by 80, you could write it as a fraction if you want. That's the same as a half or 0.5. So whichever you want to put for that. All right, so what that means then is our new scale is 1 inch equals a half of a foot, or 5/10 of a foot. So that answers one of their questions. And then the other question is just what the height is going to need to be on the new mural. So from there we can just do a proportion. So 1 inch is 1/2 of a foot. And then we're going to try to figure out, remember our actual height was 32 feet. We're going to try to figure out what height we need to make this. That's going to be proportional to that by using this scale. So always where the 1 is, that's where your easiest pattern is going to be. Just make sure you go towards the variable. So if you're going towards the variable to get from 5/10 to 1, well, if you divide something by itself, you get 1. So if we do 32 divided by 5/10, basically dividing into halves, if we have 32, we divide them into halves, we're going to have 64. So that would be 64 inches would be what the height would need to be in order to make it proportional and have the width be, or the length be 80 inches.